Hello friends, today I am discuss the mechanical system. In case of mechanical system, two type of motion is getting here. One is a translational motion and other is a rotational system. And translational system is that nothing but this is for motion take place along a straight line. And rotational system motion of a body about the axis. Now first case we are considering for the case number one for the when the body is rest on like that applied for the translational system. Here three type of force we have to considering here. First one is the inertia force. Mass is getting here. Here applied force your ft and corresponding the displacement of x of t. Then mathematical expression force F of mt is equal to mass into acceleration. এখন then at is equal to v into dv by dt. Then and v is equal to, if you know that dx by dt, that means your F of mt is equal to m into d square x t by dt square. Next, number 2, you have to consider for the damping force. So damping force is similar to same thing like that. Here you have to apply it for the applied force fd in this direction, and corresponding the x is displacement with respect to the applied force. Now in these cases, this is the condition for considered as a viscous friction. Then f of dt is equal to b into vt, and then b into dx. V means for dx by dt, then b into dx by dt. Now here b is equal to damping coefficient. Similarly we have to consider for the uh, spring force system. uh, Yes, k is considered for the spring constant. Then f of kt is equal to k into xt, or f of kt is equal to k into integration of v into t into dt. Now in this case, translational motion, three force we have to consider here. One is the inertia force, next is the damping force, and third one is the spring force. Now in these cases, we have to consider for the rotational system. This one is the rotational system. That means the motion of the body about the axis. So similarly, same cases we have to considering for the rotational body here. T is the applied torque here, and J is the moment of inertia, and theta is the angular rotation, angular displacement, and omega t is the angular velocity. Now here T1 applied torque is equal to J into alpha into T. Here J is the moment of inertia and alpha T is here is the angular acceleration. Then T1 is equal to J d by dt into omega t. Omega t is the angular velocity. Now you have then you have to omega t is converted to in the angular displacement. Then t1 t is equal to j d square theta t by by d square theta t by d theta. With respect to here d omega t is equal to here d square x by dt square. So same case here, damping torque Td is equal to B into Wt and B into dt into theta t. Now here spring constant, this one applied torque, same case, T into theta t is equal to that means T theta t is equal to K into theta, which is similar to that of the linear motion. Now one thing here, mistake here, look at here, this one is the J into d theta. Now For compare with the table for that here, be careful on look at here, translational motion, rotational motion, force Ft, force F, and torque, acceleration A and angular acceleration alpha, velocity V and angular velocity W or omega, displacement X, angular displacement theta, mass M, moment of inertia J, then damping coefficient B and rotational or damping coefficient here B. Okay, now so regarding that we are considering for the or applying for these cases, we have been considering for the D'Alembert principle. Look at here, D'Alembert principle. This is for the one mechanical system. This is spring constant K, gas spot B, and mass M. Now this mechanical system, here we have been first we have been considering for the inertia force, applied force, inertia force, F of mt is equal to minus of m opposite direction by m into d square by dt square into xt, and damping force Fd is equal to minus b dt into xt. Applied force here downward, so automatically resist force of the opposite direction, so that's why minus sign will become, and c is equal to spring force, F of kt is equal to minus of kx. Now summation total force is equal to 0. Applied force is equal to resist force or summation total force is equal to 0. So all of the force we have been getting is equal to 0. So this is the expression of that for the this one. And similarly same case rotational body. This is rotational body. So same case we are applying and for the D'Alembert principle, and this is the expression. Now we are taking for the one example. Look at here. First case, draw the free body diagram and write the differential equation. This is your mechanical system. Now in this case, at first you have to draw the free body diagram. What is free body diagram and how to draw? Look at here. So first case is your applied force here Ft, and downward direction this mass is equal to downward x1, and correspondingly if you applied force your Ft in with respect to that m1, so corresponding x2 displacement m2 in downward, and here air hinge is getting here. Now so first cases we have to consider for the mass m1. So mass m1, Ft is acting downward. Look at okay, and resist force like that. Here m1 into a, this is your m1, this is your m1, m1 into d square by d square x1 by dt square with respect to t, and here k1 into x1 minus x2. Why you have to consider for here x1 minus x2? Because here x1 is the connected with m1, and correspondingly here k is connected with the x2. So that's the resultant displacement in here x1 minus x2. Now in this case for b1 case, so b1 into d by dt into x1 minus x2. So similarly same process or same thing or logic you have to apply here. B1 is connected with m1, and another point is connected with the x2. So correspondingly resultant displacement is your x1 minus x2. So this is for the figure diagram for the mass m1. So correspondingly you have to draw the figure diagram for the m2. So look at here. This is your m2. So be careful here. One thing here, this one k1 into x1 minus x2, and b1 into d dt by x1 minus x2. So these two force now in these cases, this is what actually is downward. Remaining force actually is the upward direction, opposite direction. So here look at here, be here and here hinge here, no another displacement here. So only for your k2 into x2, b2 into d by dt into x2, and m2 into d by dt square into x2. So like that means here in case of your Fibonacci diagram for mass m1, Ft is equal to remaining addition of this one, these three force. Now in case of your mass of m2, these two force is equal to this force, and this force. So three force you have to adding here. So this one equation 1, and this is another equation 1. Now so similarly problem number 2, look at here. write the differential equation describing the dynamic of the system. So look at here, this is your dynamic mechanical system, and write down the dynamic equation. So be careful here, no frictional force is to be considered here. So only force will be applied force considered, and frictional force, that means your Dasper force or B1 and B2 is equal to 0. Viscous friction force is equal to 0. Look at here. So now in this case, your applied force, your M applied force, we have to draw the Fibonacci diagram. So this one applied force here in this direction. So automatically this force you have to apply direction, the resist force opposite direction. So that's why you have to draw the here m1 into d square x1 by dt square. And here another force is x here, k1 into x1 minus x2. K1 into x1 minus x2. So this is for, that means your ft is equal to these two force. So consider for that. Now similarly for your m2, here k1 into x1 minus x2, x1 minus x2 equal to m2 into opposite direction, m2 into d square x2 by dt square into k2 into x2. So that means this force is equal to remaining these two force. So now in these cases, you have to find the, from equation 1 and equation 2, you have to find the x1 is. And substitute the value of x1 is in equation number is 1. From this equation, you have to find the value of the x1 is. Now this x1 is value you have to substitute from the equation number. This is your equation number is 1, and this is your equation number is your 2. So from this equation, already find out the x1 is from equation 2. Now this x1 x value you have to substitute from the equation number 1. Then you have to find the value of the transfer function of the, look at here, x2s by fs. So this is for their given transfer function or required transfer function. Now next problem number 2. So same problem, type of problem. Look at here. Now in these cases we are considering for the damping force FC1 and FC2. Applied force Ft. Look at here. So now in these cases we are considering for the draw the Fibonacci diagram. Remaining calculation automatically you have to know. Look at here. Be careful. For this is for your mass M1. So Ft applied force, and opposite direction, this one in this direction. So that's why I consider for the opposite direction. And remaining three force. Look at here. FC1 d of x1 by dt. Next is your m1 d square x1 by dt square, and after that your damping despot b12 d of dt into x1 minus x2. Here result in x1 and here minus of x2, because the despot is connected with the node of x1 and x2. So now in this case we have to be considering for the summation of force is equal to Ft is equal to this force is equal to, that means Ft is equal to this force is now three forces. 1 2 3 and 4 forces. So 1 2 3 4 forces. Okay. So similarly you have to find that for the M2 case. Look at here. F of this in this case. Here now in this case B of 1 2 is applied force here. So B of 1 2 d of dt into x1 minus x2, and correspondingly opposite direction, this one this one and this one. Look at it. So fc1 dx2 by dt, k in k2 into x2 into and m2 into d square x by dt square. Now from this case, for diagram of the m2, this force is equal to this one plus this one and this one. So look at here, be careful. This one b upon 2 d by dt into x1 minus x2 is equal to m2 d square x2 by dt square plus k2 x2 plus fc2 d of x2 by dt. this one. So now, so equation 1, this one, if you consider this is your equation 1, now this is your equation 2. Now from the system equation for mass m1, f this one, this is for your s domain, so that's why you have to consider for the s domain. Here double derivative, so that's why s square is considered. So single derivative for single s is considered, and no derivative because no s term is coming here. Now from these two equation you have to eliminate for the term of x1. Okay, and you have to find the value of the x2s by fs. So this is your required transfer function. Now this is for the discussion for your mechanical system, rotational body, how to find the transfer function, or basic idea or getting problem how to solve. So this is for your mechanical system problem, how to solve and how to tackle this problem. So this is for that. So I think this problem is your this type of problem is your clear. If in doubt, then all of you comment here. Okay, bye. We'll meet over the next video.